Alright, welcome back everybody. Here we are, our fourth and final video on integration by parts. This is going to be the second video on using integration by parts, the part 2 lesson. In this video, we're just going to go through some examples of using tabular integration. Alright, so here we go. I'm going to go ahead and set up my table for my tabular integration. And like I said last time, I use a 3-column table. I use U and then my signs and my DVs. So I'll start with my U and my DV, and then a plus sign. And then I'm going to go with my derivatives down this column. Until I get to 0. So I keep taking the derivative of that u term until I get down to 0. Now in this column I want dv and its integrals. So the integral of sine of x is negative cosine of x. And the integral of negative cosine of x is negative sine of x. And the integral of negative sine of x is cosine of x. And the integral of cosine of x is sine of x. Now I have my whole table filled in. And now it's just a matter of multiplying these out to get my integral. Down the diagonal, x to the third times a plus sign times negative cosine of x makes negative x to the third cosine of x. 3x squared times a minus sign times a minus sine of x. The minus and the minus make up for a plus. It's plus 3x squared sine of x. Down this diagonal, 6x times a plus sign times the cosine of x. It's plus 6x cosine of x. And then 6 times a minus sign times sine of x, minus 6 sine of x. And last but not least, don't forget your constant of integration. And there's the integral of x to the third sine of x using tabular integration. So organizing it this way can save us a whole lot of writing, and it's a reasonably simple method for finding these integrals when we're using multi-step integration by parts. Alright, let's go on. I've got an example 5 and an example 6 here yet. Alright, so example 5, integral of x to the fourth cosine of 2x. First thing I'm going to do is, again, set up my table. Got my u's and my dv's. I start with my original u. And there's my dv. Here we go, alternating signs. Then my derivative, minus sign, my derivative, plus sign, my derivative. Got to extend my table here a little bit. Minus sign, my derivative, plus sign, my derivative, and I finally reached 0 in that u column. And now in the dv column, I want to integrate all of these. Now don't forget to apply the because I've got a 2x inside here, I need to think about this. I'm not going to actually go and write all the substitutions for this, but I do need to think about it. When I take the integral of cosine of 2x, and I'm working backwards, I mean, that's going to be related to the sine of 2x, but the derivative of sine of 2x, because of the chain rule, is twice this, 2 cosine of 2x. So I've got to remember to multiply that by a half whenever I integrate. The integral of sine is negative, so this is going to be negative 1/4 cosine of 2x. And the integral of that is going to be negative 1/8 sine of 2x. And the integral of that is going to be 1/16 cosine of 2x. And then finally 1/32 sine of 2x. And now I've built my entire table. And once I built my entire table for my tabular integration, it's tic-tac-toe time. Down the column, x to the fourth times a plus sign times 1/2 sine of 2x gives me a positive 1/2 x to the fourth sine of 2x. Next diagonal, 4x to the third minus sign minus 1/4 cosine of 2x. The minus signs cancel each other out. And 4 times 1/4 is 1. So this just turns into plus x cubed cosine of 2x. Next one down, 12x squared times a plus sign times a negative 1/8 sine of 2x. So that's going to be a minus sign. And 12 over 8 is 3/2. That's 3/2 x squared sine of 2x. My next diagonal, 24x times a minus sign times 1/16 cosine of 2x. It's minus 24 over 16 is again 3/2. Multiply down here. 24 times a plus sign times 1/32 sine of 2x. So it's going to be a plus sign. And then 24 over 32 is 3/4 sine of 2x. And don't forget your constant of integration. And boom, there's the integral of x to the 4th cosine of 2x dx using tabular integration. Excellent. Very cool. Very cool. All right, let's look at example 6. This is from the 2008 released exam, BC exam. It is multiple choice number 22, which would have been a non-calculator question. The table below gives values of f, f prime of x, g, and g prime of x for selected values of x. If the integral from 0 to 1 of f prime of x, g of x, dx equals 5, then what does the integral from 0 to 1 of f of x, g prime of x, dx equal? So we're trying to find the integral from 0 to 1 of f of x, g prime of x, dx. And so we're really doing integration by parts here. This is the integral of u, where u is the function f of x, times dv, where dv is the function g prime of x dx. And therefore du is going to be f prime of x, and v is going to be g of x. And so this integral is equal to u times v. Now we haven't done any integration by parts with limits of integration yet, but I want to evaluate this f of x, g of x from 0 to 1. So I'm just going to put that there to remind me about that later. That's equal to that minus the integral of v du, which is the integral of f prime of x, g of x, dx from 0 to 1. Conveniently, we know the value of this integral. It's right here. It's 5. And so, So the integral from 0 to 1 that I'm looking for is going to be f of x, g of x, evaluated from 0 to 1, minus 5. So how do I evaluate this? I substitute in the upper limit of integration, minus what I get when I substitute in the lower limit of integration, minus the value of this integral, which we said was 5. And now I can look up values from the table. This is going to be f of 1, which is 4, times g of 1, which is 3, minus f of 0, which is 2, times g of 0, which is negative 4, all minus 5. This is 12 plus 8 minus 5, or 15. And so our correct answer is E. All right, that brings us to the end of this video, and finally to the end of the topic of integration by parts. Come on back next time for section 6.12, where we'll be doing integrating using partial fractions. All right, have a great rest of your day, everybody. We'll see you then, and enjoy yourself. Bye-bye.